Hello and welcome to the section 3.3 lecture. Today we're going to look at subtracting rational numbers. So in 3.1 we looked at what a rational number was. In 3.2 we looked at adding rational numbers together, and today we're going to look at subtracting rational numbers. I'll go ahead and let you speculate as to what you might think might be coming next. Okay, but as we look at subtracting rational numbers today, we're going to look at starting with just positive rational numbers, which is really something that we should be able to handle relatively easily. But let's go ahead and look at what we have. It says here the temperature on an outdoor thermometer on Monday was 5.5 degrees Celsius. The temperature on Thursday was 7.25 degrees less than the temperature on Monday. So what was the temperature on Thursday? Well, it should be the case that if on Monday it's 5.5, and then on Thursday it's like Monday minus 7.25, we'd be looking at the temperature on Monday being 5.5 and on Thursday being 7.25 degrees less than Monday. So we're going to start at that 5.5 and we want to go back 7.25. Now how you do that is really up to you, especially on a number line like this. If I had my own number line, I would make it a scale that worked out really well for me. Even though it would have to probably be kind of a longer number line, I'd probably have something like, I don't know, maybe 0 right here. And then I'm thinking like 1, 2, 3, 4 is 1. 1, 2, 3, 4. Let me make that a little bit bigger. 1, 2, 3, 4 is 2. 1, 2, 3, 4 is 3. So I'm making kind of these smaller grid lines, smaller segments of the number line that are each 1/4. But this one, they don't give it to us, and most of the problems that we're going to see, they have a number line done for us, at least made for us, and so we kind of have to get creative on how we move. Let's move back a half. So 0.5 takes us to 5. And now I know that somewhere I'm going to have to move like 0.75 because I've gone halfway and I've got to get to 0.25. So I've gone past my 0.25 that I have available as a decimal. So let's go 6 units. 1, 2, 3, 4, 5, 6. And then I want to go, so this is my 6 units, and then I want to go 0.75 as my last one. And if I look at these and kind of add these together, I do get 7.5. Since I'm moving to the left, that means subtract. Okay. And we end up with 1.75. Let's find the difference of these ones. So I've got negative 6.5, which is right here. It's on my number line, so that's good. And I want to subtract 2. And we can look at that a couple different ways. The way we looked at it with integers was that subtracting 2 was like adding a negative 2. And that reassures us that we're going to be moving left. So in order to move left 2 on this number line, it's not 2 lines. I'd get people that would answer 7.5 right here because, yeah, I moved 1, 2. But each one of those moves was only a half because this is negative 6.5 and this was negative 7. So I have to move 2 lines each time to get me here at negative 8.5. The next one, I'm going to start at 1.5. Here's 1, here's 1.5. And I want to subtract 2. So again, to subtract 2, since each line, each step is 1/2, I have to move 2 units to get 1, 2 spaces to get 1, and then 2 more to get 2. And where does that end me? It ends me halfway between -1 and 0, which is -1/2. Last one of these, -2.25. We're going to have to kind of guess where that's at, but it's somewhere right here, a little bit past 2, or -2. And then I want to move left 5.5 more. Okay, so let's move our 5, and then we'll figure out what a 0.5 move looks like. So every time I move, I'm going to be going to that 1/4 spot, that 0.25 spot. So I'm going to move just past the 3 for 1, 2, 3, 4, 5, and then I need to move a half. And I was at 0.25. I was at -7.25. And I want to move 0.5 at the end. That's not going to take me to 8. It's going to take me to -7.75. And that's what we get there. Let's look at subtracting negative rational numbers. So a problem like this says, during the hottest week of the summer, the water level of the Muskrat River was 5/6 of a foot below normal. The following week, the level was 1/3 of a foot below normal. What was the overall change? Okay, so we want to go. Our ending value minus our starting value. Okay, so -1/3 for 1/3 foot below, and then minus -5/6 for -5/6, or for 5/6 of a foot below. So we start at -1/3. Yeah, so they split this into 1, 2, 3, 4, 5, 6. So that's actually -2/6, which is the same as -1/3. And then I want to move to the right because I'm subtracting a negative, which is actually, like, the easier way to look at this is -1/3 add the opposite of this. So it's like adding 5/6. Since there's 6 lines between 0 and -1, this number line is written to a scale of sixths. So I just have to move 5 spaces. 1, 2, 3, 4, 5. We end up right there, and that happens to be 1/2 of a foot. It says work with other students to compare addition of negative numbers on a number line to subtraction of negative numbers on a number line. You know, we don't have other students around while we're doing these videos, so this is a little bit tough, but when we add negative numbers on a number line and subtract negative numbers on a number line, it's actually the opposite. Okay, and here's how I'm going to show that. We're going to go addition, and we're going to look at subtraction. Okay, I should say addition of a negative. And so I'm looking at something like 1/2 plus -3/4. Okay, and so to do that, I'm going to end up moving left, because we are talking about on a number line. Move left. And subtraction of a negative if I use the same numbers in the same problem. So if I subtract -3/4, on this one, it's the same thing as saying 1/2 plus positive 3 over 4. And for that, I would move right. Okay. It says compare methods used to solve example 1 and example 2. So the ones that they did is what we're looking at here. Some comparisons. Other than what's set up here, because basically what's going on is in example 1, we're subtracting a positive. In example 2, we're subtracting a negative. Okay, so there's the obvious which way do you move. That's a clear difference. Okay. But other things about the methods, number lines, that are written in a nice way are helpful. And so what I mean by that, just like in this problem up here, it was broken down into sixths because I had to end up moving a certain number of sixths versus some of the your turn problems that we did where we had to kind of guess where like 1/4 was. So number lines that are written in a nice way are helpful. Okay. Let's take a look at adding the opposite. So this is kind of what we kind of did on the problem, even though I don't know if we were supposed to yet. It says that Joe is diving 2.5 feet below sea level. He decides to descend 7.5 more feet. So how many feet below sea level is he? So -2.5 is where we start. And then we want to move our 7.5 units. When we're subtracting, we want to move 7.5 units to the left. So I'm actually going to move my half and then move 7. Oop. Not too happy with how that looks. So we end up at -10. And it says that we're moving 7.5 units to the left because we're subtracting a positive number. Okay, so Joe is 10 feet below sea level. Okay, let's look at these different problems here. It says -3 -3. So to do -3, we want to move left. And we end up at -6. And for the bottom one here, it says -3 plus a -3. When we're adding, and we're adding a negative, we also want to move left. So we still get to -6. Okay, and so what this conjecture wants us to say is that if we have any number minus some other number, they can be the same, but it's easier if they're not. That is the same thing as taking that any number and adding the opposite of the second number. Okay, and that's exactly what this says here. They use P and Q. Okay. Now we want to find the distance between two numbers. It says a cave explorer climbed an elevation of from an elevation of -11 meters to an elevation of negative 5 meters, and what's the vertical distance that the explorer climbed. So to do this, we want to start at negative 11. Count the number of units on the vertical line up to negative 5. So we're going to go ahead and do that from negative 11. The other one we're concerned with is negative 5. So how many units do we have here? 1, 2, 3, 4, 5, 6. I'm going to put the arrow this way because he started at negative 11 and went to negative 5. So he climbed, I don't know if this is going to give too much away, but I'm going to say he climbed up. How many did I count? 1, 2, 3, 4, 5, 6. 6 meters. That means that the vertical distance between negative 11 and negative 5 is 6 meters. If we find the distance between the two elevations, and we want to use absolute value to figure it out, if I do this, and I even think about adding the opposite, I'm going to get negative 6. And one reason for that is that we're actually talking about a change problem here. And when we talk about like a change in height, just like if we talked about a change in temperature or a change in anything, we want to start with our final height. And then we want to subtract our starting height. I'm just going to say our start height, which we don't do here. We actually did that backwards. That's why we got a negative number. If we would have done it the other way, we would have got a positive number. But if we take the absolute value of this negative 6, absolute value of negative 6, remember absolute value talks about the distance away from 0, so it strips away any negative signs. And so the vertical distance is 6 meters. You might even say that it's more specifically positive 6. Distance is always positive. Okay? Doesn't matter which way you subtract values when finding distance. It actually does. And I'm going to say, because we talked about this yesterday, I'm going to say because subtraction doesn't commute. Meaning, and we've done problems like this in the past, that negative 11 minus negative 5 is not the same as negative 5 minus negative 11. So the order does matter. The which way you subtract them matters. Okay? But we can get around this, just like we did in this problem. I'm going to say that you can fix it by taking absolute value. It says, would the same method work if both the numbers were positive? So what they mean by this is, does taking the absolute value work if both the numbers are positive? And then what if one was positive and the other was negative? Both positive works. because let's say that he was a parachuter, right? And he starts at, for some reason, 11 meters and ends at 5 meters. I don't think that would work, but if we're talking about how far he travels vertically, we're looking at 5 minus 11, which is -6. He moved 6 meters, so if we take the absolute value of -6, we get that he moves 6 meters. So that method works. If one's positive and one's negative, let's say that he jumped out of a helicopter at 11 meters high and dove down into water at 5 meters below. So that would be like -5 minus 11. Well, you got to think about how far he actually traveled in this one. He started at 11, went down to 0, and then past 0 to -5. Okay, so this one also works. So and let me finish this, I guess. So in this problem, he actually moves, he goes down 16 meters, but the distance he traveled, if we take the absolute value, is 16 meters. That's how far he traveled. Positive and negative also works. Okay, so the distance between two numbers, and when you're trying to find the amount of space in between two numbers, it doesn't necessarily matter the order, but you do have to take the absolute value. Basically, pick the positive version of your answer. Okay, and that'll be it for today. Probably want a code word. Since we're here, we're going to say that our code word today is going to be distance, because that was heavily covered in this last problem. Okay, so today's code word, distance. Have a good day. Write down any questions you have, and I will see you in class.